Hello students! Till now we have seen the trigonometric ratios of 0 degree, 90 degree, 30 degree and 60 degree angles. We have also calculated them from triangles and tabulated them like this. In today's video, let's understand and calculate these ratios for 45 degree angle. So let us bring our unit circle back. And now make a triangle with this angle equal to 45 degree. Yes, here theta will be 45. Now look, this angle B is 90 degree and theta is 45. Therefore, this second angle will also be 45. We already know that sides opposite to equal angles is equal. This means two sides opposite to these two equal angles will also be equal. Therefore, triangle AOB is isosceles one, and thus hypotenuse AO is equal to 1, which is the radius of this circle. That is, AB is equal to OB. So in this circle, if AB is sin theta, then OB is also sin theta. Similarly, we can also say that OB is equal to AB, which is equal to cos theta. In short, the value of cos theta and sin theta will be numerically equal. Then what about tan theta? Yes, you can see from the diagram it increases as we move theta from 0 to 45. But we can't really say anything about its absolute value, isn't it? Yes, we can just say that it increases. Well, one way is to take a ratio of sin theta and cos theta, which will be 1 in this case because sin theta and cos theta are equal. But let's now calculate their actual values from the triangle using trigonometric ratios. We take this triangle out like this from the circle. So now in triangle AOB, right angled at B, if one angle is 45, obviously the other angle is also 45. We know it's an isosceles one. Therefore, let us say OB equal to AB equal to A. Then let's apply Pythagoras theorem to this triangle. So we have AO square equal to AB square plus OB square. Now putting values of AB and OB in the equation, we get AO square is equal to A square plus A square, that is 2A square. And therefore AO is equal to root 2A. Thus, hypotenuse AO is root 2A. Using the definitions of the trigonometric ratios, we have sin theta, which is here sin 45, as AB upon AO. So let's substitute the values and we get A upon A root 2 equal to 1 root 2. Similarly, cos 45 will be OB upon AO, whose value is 1 by root 2, and tan 45, which value is 1. Now what about their inverse ratios? Yes, cosec 45 will be 1 upon sin 45, that is root 2. Sec 45 will be 1 upon cos 45, which is again root 2. And cot 45 as 1. Now we have all the values for this table. And let us see them together. As you can see, we saw that when theta increases, the values of sin theta also increase from 0 to 1, while the value of cos theta decreased from 1 to 0, while tan theta also increased from 0 to infinite. Well, recall students, I have already told you why infinity is written as non-defined in this table, or why we can write infinity also as not defined. Now you will ask me, do we need to remember this whole table? I would say yes. This table and these values are really important for solving all the problems in trigonometry. But don't worry, you actually need to remember only these three ratios. Remaining three are just inverse of sine, cos and tan respectively. Well, to make your life still easy and simple, let me tell you, even out of these three, you need to remember only these sine values. That is only one row that you have to remember. The last two are simple. Let me tell you. You need to focus and remember only these 5 values for sin theta. In order to complete the cos table, simply fill in the values of sine in a reverse manner like this. That is, value of sin 90 is equal to value of cos 0. Similarly, value of sin 30 is equal to cos 60. And note that value of sin 45 and cos 45 are the same, that is 1 by root 2. For tan values, we know that it is the ratio of sine to the cos. Therefore, to get the values of tan theta, just take the ratios of values of sine and cos of the corresponding angle. Like tan 0 is sine upon cos 0, which is 0 upon 1 equal to 0. Similarly, tan 30 is sine 30 upon cos 30, which is 1 by root 3. As here, root 2 cancels out, and so it would be 1 by root 3. Now again, tan 45 is ratio of 1 by root 2 to 1 by root 2. Root 2 cancels out, and we get 1 upon 1, which is 1. And so is the value of tan 60 and tan 90. Now wait, for tan 90 it is 1 upon 0, which is we know when 0 is in denominator, the value is infinite. And thus in this table we need to remember only the values of sine. Cos is the reverse order of sine, and tan is nothing but ratios of sine upon cos values. So in the next video we will see the trigonometric ratios for complementary angles.